I'm using MI1 here, but if you double click, you can see I have the ability to select a memory integer, a memory long, or also a double word. So you essentially just have to assign an operand to the analog input so it can hold that value that's coming into the controller. We'll take a look at the analog output. It's essentially identical to the analog input. You have to define the type of output, whether it's a 4 to 20 or 10 volt. I'm making sure I select voltage in this case because I want to feed my analog output, my 0 to 10 volt signal, into my analog input for this demonstration. But same idea, you select the type of signal that you want to send out and also an operand value to assign as well. So whatever bit value I have in this case is going to be sent out from the controller as a bit value, which is also equivalent from 0 to 10 volts in this case. So that's all that really needs to be defined in the hardware configuration. I've defined my analog input, linked an operand. I defined my analog output and linked an operand as well. So as far as the ladder logic, I start off with defining a PLC name. As we've discussed before in our webinar series, it's always a good idea to define a PLC name. Any of our free utilities generally require that you specify a PLC name to be able to communicate. Remote operator that I was just using in the connection settings, it requires that you define a PLC name. Same is true for any of the SD cards and so on and so forth. It's always a good practice to get into defining a PLC name for your project. PLC name is found simply under the COM menu, set PLC name, and you have the ability to define an alphanumeric value. It is case sensitive, that's something to keep in mind. But you want to make sure you link that to an SP2 power-up bit. It only needs to be defined one time. The single scan is what SP2 is saying. Whenever you start the controller up initially, you need to just pulse that one time for the PLC name. So in my Net2, Net2 and Net3 are really just controlling the push buttons that I had on the screen. I was incrementing my voltage up and down. Those buttons were linked to MB0 touch property and MB1 touch property. I'm using a compare statement, a less than block, so I'm saying if my analog output is less than 4095, which is my max value, also equal to 10 volts. So if my analog output is less than 10 volts, I'm going to increment that analog output. So my MI0, my AO, I'm going to add 91 bits to that. So basically I just have this limitation here, the compare statement, to make sure I don't go any higher than 10 volts. I don't want to increment the analog output higher than the supported value of 4095 or 10 volts, same difference. The down button is the same idea. If the value is greater than 0, I want to go down. I want to go down if it's greater than 0. And just use 91 bits arbitrarily to increment or decrement. You can really do whatever you want in here, but I just had 91 bits. Now the linearization, the scaling factor. This is found under the Math menu, Linearization, and the Linearization function block. Generally, you want to have this tied directly to the rail so that it's always scanning, and it's always performing the linearization, the calculation. So if I open up the block, you can see there's 6 parameters that you need to define. You have your x1, y1, x2, y2, your x input, and your y output value. So we saw this on the graph in PowerPoint earlier. I'll pull it up once more. We have our x0, our x1, our x2, our y1, and our y2. So we have 0 to 495, and 0 to 20. So this is where the graphical representation, the scaling factor, is equivalent to these values that you define inside the linearization function block. So my x1 is going to be 0. My y1 is also 0. Those are our two lower limits in this case for a 0 to 10 volt analog input value. My x2 is 4095. Again, this was just grabbed from the spec sheet. 10 volts is equal to 4095 is what this is saying. My y2, I have it as 100 here, but what I'm really doing, we saw in the demo before, I had 0 to 10.0 volts was my range. So I'm adding in a decimal offset essentially of 1 decimal place. So my 100 here is really saying 10.0. So I'm scaling it with 1 decimal place in for my y2 value. So what you can think of it as, your x values are really the value that's inside the actual operand, 0 to 4095 in this case from my x1 to my x2. The y values are the scaled values, so that's the engineering units that you want to use, whether that's, here we just use the voltage from 0 to 10.0 volts, but this can also be, for example, a pressure value. If you have a 0 to 10 volt sensor that's outputting a pressure, you can have it be, your y1 is 0 and your y2 is 500 psi. So you can use it to scale to engineering units, whether that's voltage or your actual type of transducer pressure, whatever you're using really. Your y2 value, your y values is the scaled value that you're trying to achieve. The x is just your input, so your analog 0, and your y output is your scaled value. In this case, the linearized analog input is tied to MI2. Is that clear? So that was an overview of the linearization function block. Now I do have to mention there's two ways you can do linearization. You can do it via the function block that we just looked at, and if I hop over to the HMI, I'll show you we can also linearize via the HMI with no ladder code required. If I open up my voltage for the analog output, the variable, you can see that I have it linked to my MI0, my analog output. And the fields are blank here because I'm on the silver XP theme. But if I open up the operand value, the 0 is defined for the x1, a constant value of 4095 is defined for my x2, my minimum value, I have again 0 on my y1, and I have 100 or 10.0 on my y2 value. So when you select this checkbox for the linearization, it allows you to essentially do what we have just done on the ladder before, graphically in this HMI variable. Now, it's important to point out if you want to do any sort of math calculations or use the linearized value anywhere else in your program, it's best to do it via the ladder. So when I'm scaling this 4095 10 volt value in the numeric variable, it's only scaling it for the display here. It's not going to be available anywhere else in the application. So as I mentioned, it's best to generally linearize by the ladder, but I just wanted to demonstrate here that it can be done via the HMI, but again, it's only for this variable. It's not saving this 10 volt value anywhere else. It's not available anywhere else in the application for use. And let me just point out as well the base format I've selected as 2.1. This just lets me enter in on the HMI a value of, if I enter in 999, it will, be 99.9 volts. In this case is what it's showing on the HMI here. So if I enter in, 100, it will give me my 10.0 volts as well. and cancel out of here. So this variable here, you see there's no linearization selected. This is how I'm really showing the raw bit values that's inside my analog output, my MI0. I'm also displaying the analog input with a meter variable. So the meter variable is found under the graph menu. And then we have bar graphs and also meters. We can take a look at the meter. There's a bunch of parameters you can define, whether it's the shape of the variable. If I move the radius and also the arc angle, you can see it's changing on the screen right now. The rotation, I can move it around. Just gives you options to customize how you want to display the variable. The needle, again, you can define the thickness, the length, center radius. You can define the ticks and the labels and the ranges. The main parameter that you need to define is the link. I have it linked to my linearized MI2, my analog input value. This is from the ladder before. My Y value from the ladder was MI2, so I have it defined as the link property to display my voltage value. So that's all that you really need to define for the meter. I guess also I should point out in the range here as well, I have my decimal format as 9 and 1. Again, this is allowing for the 1 decimal place offset. If I bring this down to 0, you can see it's showing my actual 100, but I want it to display my 10.0. So I have my 1 decimal place defined, and on the HMI, it will give you that 1 decimal place as well. So we can talk about the trends as well. The trends are defined first on the left-hand parameter here. You can see under the hardware config and ladder and HMI, one of the options is trends, and I've defined my first trend as analog. So if I right-click on analog and go to properties, you can see this is where we define the sampling interval, as well as a run stop bit and a history of samples. So right now I have it defined so that it will take a sample of the linked operand every 1/100th of a second. The places here go from hundredths of seconds, seconds, minutes, and hours are the 4 different divisions here. History of samples, how many maximum samples we can go back and scroll through the history of on the trend variable.